everyone. In our first technique for Maclaurin series, we have the derivatives. So if you look at the MF26, right, you notice that we can approximate any function using our derivatives. So in this MF26, you'll see that fx can be approximated to f0 plus first derivative 0x plus f double prime 0 over 2 factorial times x squared plus f triple prime 0 divided by 3 factorial x cubed plus all the way to, you see a pattern, right? The nth derivative x equals to 0 divided by n factorial times x to the power of n, so on and so forth, right? So let's say we have this example. We have the graph y equals sine x plus e power 2x. And the question is phrased such that sure, a variety of ways to actually frame the question. You can have, let's say we want to expand or express this function y equals sine x plus e power 2x using the Maclaurin series found in the MF26 or through differentiation. It really depends on what the question really want you to do, right? If you say through differentiation, use only differentiation. If you say to use MF26, doesn't specify any formula, you can use either of the formulas over here. Then there will be a limit to how much they want you to expand this to. So they can be telling you to, oh, okay, up to x cubed, or they can phrase it such that x power 4 and higher powers of x are ignored or simply neglected. Okay, so basically just follow whatever the question says. I'm just trying to cover as many possibilities as I can. Okay, so since you're talking about differentiation, right? The question only asks for differentiation. Let's differentiate that. So we have y equals sine x plus e power 2x, right? Then you want to differentiate, you want to find up to x cubed, so you define until the third derivative. So let's start by the first derivative. Sine x become cosine x, e power 2x become 2e power 2x. Second derivative, cosine x become negative sine x, 2e 2x becomes 4e power 2x. Third derivative, minus sine x become minus cosine x, 4e power 2x becomes plus 8e power 2x. As you notice in the formula, we are going to substitute all the x into as 0. So we have x equals to 0, we have y equals to sine 0 equals to 0, plus e power 0 is just 1, dy dx equals to cosine 0 is 1, plus 2 e power 0 is plus 2, so 1 plus 2 equals 3, d2y dx2, sine x is 0, so that's 0, e power 0 is 4, and then d3y dx cubed minus 1 plus 8, so you get 7. So now what do you do now? We just follow the formula, right? So if y equals to sine x plus e power 2x is approximated to f0, so 1, plus dy dx is 3, so you have 3x, right? Then f double prime 0 equals to 4 divided by 2 factorial x squared plus 7, right? The third derivative is 7 at x equals 0, so 7 over 3 factorial x cubed, okay? Then we therefore have 1 plus 3x plus 2x squared plus 7 over 6x cubed. So this is one way to do it, where we use an approximate sign. Another way is we can use an equal sign, and then we put the same answer, 1 plus 3x plus 2x squared plus 7 over 6x cubed. But because it's an equal sign, we need to add a ... or the ellipsis. Alright, this is important because we have omitted any other terms, right? As you can see, the actual formula includes all the way to n plus 1 derivative. Actually, it's an infinite derivative. So there we have it, the derivatives from Maclaurin series.